So the following videos are actually just extra practice questions working with reciprocal functions. So feel free to watch as many or as few as you want. Try them on your own before you actually work through the videos, just to make sure that you can identify what areas you're actually struggling with and what areas you've kind of already got down. And then you can kind of build from there. That's how we improve, right? Is identify our strengths and our weaknesses. And we're going to spend way more time kind of trying to study those weaknesses and improve them in comparison to our strengths, which we don't need to spend as much time on. So our first example is y equals 1 over 2x plus 3. So the first thing that I do is I identify just strictly some key things that I need to know. My original function f of x is linear, which means that I'm expecting one vertical asymptote, and I'm also not expecting symmetry. I'm expecting things to be on opposite sides, as opposed to when we were dealing with quadratics and we had some beautiful symmetry happening there. From there, I'm going to follow the same steps that I was doing in my previous examples. I'm going to work with my new function, my reciprocal function, and I'm going to identify a couple key things. Number one, I want to know my non-permissible values. So 2x plus 3 cannot be equal to 0 because that's in the denominator. So moving it around, 2x cannot be equal to negative 3, and x cannot be equal to negative 3 halves. That is going to be my vertical asymptote. I am also going to figure out, is my line increasing or decreasing, and getting a couple other points out of there. I'm going to choose some x values, calculate some y values. I'm going to choose them so that they kind of fall around my vertical asymptote. So I'm going to start at, this is negative 1.5, so I'm going to start at negative 3, negative 2. I'm going to go negative 1 and 0. We're going to plug those in. So we're going to go 1 over 2 times negative 3 plus 3 equals. So that's negative 6 plus 3 is negative 3, so negative 1/3. Here I'm going to get 2 times negative 2 is negative 4 plus 3 is 1. So negative 1. Alternately, 2 times negative 1 is negative 2 plus 3 is positive 1. And 0, plugging it in here, well, that takes 2x becomes 0, so it's just going to be 1/3. So again, we see that kind of opposite signs, but otherwise it is still symmetrical. And then we're going to graph this. Now, because I'm dealing with some tiny numbers, I'm definitely going to be working with some fractions in my scale. I'm not just going to go up by 1. So I'm going to go up by half horizontally. So negative 1, negative 2, negative 3. 1, 2, 3. And vertically, I'm actually going to go up by 3 because I know I'm dealing in thirds. So I'm going to go up by thirds. So I'm going to go 1 and 2. 1, negative, and negative 2. From here, I can actually start graphing. I'm going to use red just so that it shows up nicely on this grid for you. First, I'm going to put in that vertical asymptote. X equals negative 3 halves, again equals 2 because I'm not naming it, I'm naming it. And I'm going to put in my points, so I've got negative 1/3 and negative 1. I've got positive 1 and positive 1/3 here. So I've already got a sense of what my shape is going to be. curving towards my horizontal axis at y equals 0, and then going forever downward, alternately over here. I'm going to be going forever upward, closer and closer to that vertical asymptote, and forever horizontally, closer and closer to y equals 0. And that is going to be 1 over 2x plus 3. There's my graph. Okay. B asks us for some key details, so I do want to list all those. So I can already identify vertical asymptote at x equals -3/2, horizontal asymptote at y equals 0, as always. My domain in this case has that restriction of my vertical asymptote. So again, we can do this in interval or set notation. I'll do it in interval notation for this one and set notation in the next example. So it's going to be -infinity going to the left. When I get to that vertical asymptote, I have to stop before I actually reach it. I'm also going to hop over it, and just on the other side, I'm going to pick up where I left off and go to positive infinity. My range is very similar, but 0 is that place that I can't exist. So we start at the bottom. My floor is -infinity. I get to 0, and it seems like a ceiling on the left-hand side of my graph, but actually if I jump over and I go onto the right-hand side, it starts up at 0 again and goes all the way to positive infinity. Again, noting that we have these rounded brackets at those asymptotes because we never actually have those values. They are not themselves defined.